How are you guys? Welcome back to my channel. Today we'll discuss this matter of discharge, which is known as the rate of flow. Okay, we can define what is discharge. Is known as the volume of liquid passing a given cross section in unit time. Is measured in cubic meters per second. Is meter cubic per second. How that means we can tell from the SI unit that this discharge is derived from the area multiplied by velocity. Then this is an area of what? Of the pipe. This one, that means area is measured in meters cubed, or meters square. So is measured in meters squared multiply velocity. Its SI unit is meters per second, right? Mathematically, if you multiply these two at the bases are the same, we add the exponent will be m3 per second. It's how it is derived here. So in such a case, that means if we are given a pipe, we will focus on this cross section. The area will be of the cross section, and then v is the velocity of the fluid. So if you are given this form of the pipe, you see, let's say now here I call it A, this I call it B, this I call it D. Here at the flocket I can call it C, right? So if let's say you pour water here, this water will travel here, will move, reaching this point at this fork, the water will split. Other water will go that side, other water will split. They will diverge when they reach this side. Other water will go this, other water will go this. But if I've poured 2 liters of water, the system will have 2 liters. Then this 2 liter will split. That means if I want the total, if I want this water, I can simply say this water. I can simply say the water at A will be equal to the sum of the B plus D. This will be the sum of this water. If I want to know the water at A, I can sum up this if I'm given how the quantity of this water. You see. So in other words, this can tells us that the rate of flow, we can simply say to this type of pipe, we can say the rate of flow at A must be equal to the sum rate of flow at B plus QD. The rate of flow of A must be equal to the sum of the two, rate of flow of B and the rate of flow at D. So similarly, if you want the rate of flow at B, you will make the subject of the formula. You can say QB will be equal to QA minus QD. Same applies if you want QD, you will be say QD is equal to QA minus QB. This is important. You have to remember this stuff. Also, you must know at C will be the C again. At C will be the sum of the two, because this pipe is the same water that is moving here. They just split just before it split here. The water split is here. That means the quantity of this water at sea must also be equal to the sum of B and D.